The next type of calculation that we're going to be looking at is calculating the pH when we mix two strong acids together or when we mix two strong bases together. So if we mix two strong acids together, so a strong acid plus another strong acid, there's not going to be a reaction. Likewise, if we mix two strong bases together, there's not going to be a reaction. So for example, if we mix sodium hydroxide and potassium hydroxide together, they're not going to react with each other. There is no reaction. However, the total number of hydrogen ions or hydroxide ions will change, and therefore the pH of the solution is going to change. So for example, if we mix strong acid A with strong acid B, strong acid A might produce 5 moles of hydrogen ions, and strong acid B might produce 3 moles of hydrogen ions. And so as you can see, in the end, even though there's been no reaction, the number of moles of hydrogen ions has changed, and therefore their pH is going to change too. So to work out the pH when we've mixed two strong acids or two strong bases, you're going to work out the number of moles of hydrogen ions you have or hydroxide ions you have. Then you're going to calculate the concentration by dividing it by the total volume. And then once you have your hydrogen ion concentration, you're going to be able to work out the pH using the pH formula. So let's have a look at this question over here. Calculate the pH when 20 milliliters of 0.2 molar HCl and 35 milliliters of 0.1 molar nitric acid are mixed. So when you read a question, you need to first look at the two species given to you, and you need to recognize that it's two strong acids being mixed together. We're going to be looking at a variety of calculations, so it's really important that you first look at which type of calculation it is, so you're doing the correct series of steps. So over here, you can see we have two acids being mixed together. They are both strong, so it's this type of a calculation. So what we're going to do is you're first going to work out the number of moles of each acid. Okay, so we're going to work out how many moles of HCl do we have. So to do that, we're going to do concentration times the volume. So that's 0.2 times 0.02. And so that's going to give us 0.004 moles of HCl. Then we're going to work out the number of moles of nitric acid that we have as well. So that's going to, again, be our concentration times our volume. Our concentration is 0.1. Our volume in liters is 0.035. And so that gives us 0.0035. So after you've worked out the number of moles of each acid, you're going to use ratios to work out the number of moles of hydrogen ions each acid produced. Okay, so as you can see, HCl dissociates into hydrogen ions and chlorine ions. So there's a 1-to-1 ratio between the HCl and the H+. And so that means the number of HCl is equal to the number of hydrogen ions. Okay, so 0.04 moles of HCl produces 0.04 moles of hydrogen ions. Likewise over here, we have our nitric acid. Nitric acid dissociates into hydrogen ions and nitrate ions. We can see there's a 1-to-1 ratio. So that means we're producing the same number of moles of hydrogen ions. Okay, so over here, what we've done is we've calculated the number of hydrogen ions each acid is producing. So step number 3 is we're going to work out the concentration of hydrogen ions in the solution. So remember, concentration is equal to the number of moles over the volume. So we're going to do the total number of hydrogen ions over the total volume. Okay, so our HCl produced 0.004 moles of hydrogen ions, and our nitric acid produced 0.0035 moles of hydrogen ions. And we're going to divide that by the total volume. So our total volume is 20 milliliters plus 35 milliliters. So our total volume is 55 milliliters, which is 0.055 liters. And so then you're just going to be putting this into your calculator to work out the concentration. And so when you do that, you'll get 0.1363. And this is the hydrogen ion concentration. So now that we have our hydrogen ion concentration, we can just put it into our pH formula to work out the pH. So that's going to give us about 0.865 as our pH. And you can see it's a very low pH because we have mixed two very strong acids together. So the final solution is going to be very acidic. Let's have a look at this question over here. Calculate the pH when 40 milliliters of 0.6 molar sodium hydroxide and 20 milliliters of 0.2 molar calcium hydroxide are mixed. So remember, whenever you have species in a question, you need to ask yourself, is this a strong acid, strong base, weak acid, weak base? And you should be able to recognize that we are mixing two strong bases together. Okay? And we've been asked to calculate the pH. So remember, when we are looking at pH and we have bases involved, we need to use this relationship over here. The hydroxide concentration will tell us the pOH, and the pOH will tell us the pH. Okay, so ultimately we are trying to work out the hydroxide ion concentration in order to be able to work out their pH. So remember, the first step you're going to do is you're going to work out the number of moles of each base. Okay, so the number of moles of sodium hydroxide, it's going to be our concentration multiplied by the volume. Our concentration is 0.6, our volume is 0.04. So that is going to give us 0.024 moles. We're then going to work out the number of moles of calcium hydroxide that we have. So again, concentration times volume. Our concentration is 0.2. Our volume is 20 milliliters, which is 0.02 liters. So that's going to give us 0.004 moles. So step number 2 is to work out the number of moles of hydroxide each base is producing. Okay? So when we are looking at sodium hydroxide dissociates into sodium and hydroxide. And we can see we have a 1-to-1 ratio. So the number of moles of hydroxide produced, it's also going to be 0.024. When we look at our calcium hydroxide, so calcium hydroxide, it's going to dissociate into calcium ions and hydroxide ions. But when we balance it, we realize that it's actually a 1-to-2 ratio. So even when you look at the formula, you can see that there's 2 hydroxides present. And so what that means is that the number of hydroxide moles is going to be double this amount over here. So we're going to times this by 2 because we have a 1-to-2 ratio. So now that we've worked out the number of hydroxide moles each base is producing, we're going to then work out the concentration of hydroxide. So why are we interested in the concentration of hydroxide? Because once we know the concentration of hydroxide, we can work out pOH and then the pH. So the concentration of our hydroxide will be the total number of moles of hydroxide over the total volume. Okay, so in terms of the total number of moles of hydroxide that we have, that would be our 0.024 plus 0.008. And so 0.024 plus 0.008 over the total volume. So we have 40 milliliters plus 20 milliliters, which gives us 60 milliliters, which is 0.06 liters as our denominator. So we're just going to put this into our calculator and we will get 0.53 moles per liter. However, remember, that is the hydroxide concentration, 0.53 moles. So once you have your hydroxide concentration, you're now going to be able to calculate your pH. So step number 4 is to work out the pH. And to do that, we're first going to work out our pOH. So our pOH is going to be negative log 10, the hydroxide concentration, which is 0.53. And so when we put that into our calculator, we get 0.273 as our pOH. So now to work out the pH, we're just going to do 14 minus the pOH to give us a final answer of 13.73 as our pH. Okay, so the pH is equal to 13.73. So just having a look at the steps overall, what we did is we calculated the number of moles of base that we had, then the number of moles of hydroxide produced, and then worked out the total concentration of hydroxide, and then we applied the pOH to pH formula.